Hello, so today I'm going to be solving a Sudoku called X Stairways by Joseph Nehme. And the rules are pretty straightforward for this one. So we have normal Sudoku rules. In addition to that, there's two diagonal lines across the main diagonals of the puzzle. And each of the diagonals must have the numbers 1 through 9 exactly. So they're like another row or column or box where you have to have exactly 1 through 9 in them. And same for this other diagonal. In addition to that, we do have killer cages. So if you haven't seen those before, there's dotted lines that encompass 2 or more cells. And within those dotted lines, digits cannot repeat. These they wouldn't be able to repeat anyway because they're in the same box. Same with this one. But for example, this one here, it's labeled 19. This digit can't be the same as this one, even though by normal Sudoku rules they could, but because it's in a cage, they're in the same cage, they can't repeat. And also, if you add up all the digits in a cage, they will sum to the number that's labeled in the top left corner. So those are all the rules. And I saw in the description that there is a tricky break-in, but it gets simpler after that. So hopefully I'll figure out the tricky break-in. And hopefully you will too. So go ahead and check the link below. And if you'd like to try the puzzle yourself, and either way, I will get started now. So let's take a look here. Usually there's some trick with the diagonals here. So it's pretty clear that, and that's probably why it's called X Stairways, the cages are following the diagonal in both directions. So my initial feeling is something along the lines of, we know that along one diagonal, because it's the digits 1 to 9, it's going to add to 45. So I'm just going to highlight that real quick. So the green cells add to 45, and that's just because 1 plus 2 plus 3 all the way through 9 adds to 45, in case you didn't know that. So every row, column, and box in a Sudoku is going to add to 45. So that's a good number to know. I'm also seeing that if we look at the cages that are involved in the green cells, we have another diagonal going up here. So I guess I'll mark that blue. And that's going to be the rest of the cages. So let's just do a little math here. So I'm going to add up all of these cages that are part of the greens, and I'm going to subtract 45, and that's going to be what the blues add up to. So we kind of end up with like a little killer sum along that diagonal. So I think it would be good to know what that is. So 14, forgive my math, I'm not as fast as some people, but 14 plus 18 is going to be 22. Plus 19 is 41, I believe. Plus another 18 is 59. Plus 22 is 71. Plus 20 is 91. Should I do that again just to make sure? So 42 plus 18, so 42 plus 8 is 50, 60, 79, 98. Okay, I got a different number this time. I am not above using a calculator. I know some channels don't, but let's just pull up a calculator here because I don't want to make mistakes. So 20 plus 22 plus 18 plus 19 plus 18 plus 14. 111. Okay. So these add to 111. And then, of course, if we subtract 45 from that, 66 is a pretty big number, I think. How many cells are in the blue? So the blue cells add to 66. So 8 cells adding to 66. So if we just do a quick division here, that averages to 8.25. That is really high. So what is our minimum that we could add to? So this would have to be 8, 9. This could be 9. this could be 8, 9, this could be 9, and this could be 8, 9. So these are 17. So we have 3 lots of 17 plus 18. So again, I'm not above using a calculator here. Let me get that in frame. So 17 times 3 plus 18 is 69. So 69 is our absolute maximum we can add to. And if we look at our history here, we needed to add to 66. I wonder if there's somewhere I can put this that's not in the way right now. With history. All right. Hopefully that's good enough. So, of course, as soon as I click away, it's going to disappear. That means we have 3 degrees of freedom, which means that any of these can be reduced by 3, and the sum is still valid. So that's more degrees of freedom than I wanted, but it's not a lot. So I think that means we could have, for example, instead of an 8 in this cell, we could have a 5. So let's just double check that. So we'd have 2 lots of 17 plus 18 plus 9 plus 5 is 66. Yeah, and that's our goal, is 66. That's here. So this can be 5, 6, or 7. This can be 5, 6, or 7. And then this maxes out at 6. What am I doing? 5, 6, 7, and then this one too. And then this is 6, 7, 8. So those are, we can't be any less than 5 on these, and these can't be less than 6. Or we can't meet our sum. So now I'm wondering if we can do the same thing in the other direction. Let's just delete all that highlighting. So if I highlight these in green, and then the rest of the cages, this is a bit annoying. All right, well, highlight that. So these cells here, so the blues plus the greens, I guess the blues are the sum of these cages minus 45. So we're just going to sum again here. So five plus 7 plus 10 plus 18 plus 11 plus 12 plus 7 is 70. That's pretty small. Subtract 45, that's 25. So the blues can't add to more than 25. Well, they have to add to 25, I should say. Exactly. And that's tough because I think there's 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 25 over 9 is 2.7. So we can't average very high. So let's see what the minimum is here. So 1, 2. This can be minimum 1. This was minimum 5, and we can have 1, 2 in these. This is 1, and these are 1, 2. So I think this overlap is very much on purpose. So now we can just add up. Our goal is to get 25. So this adds to 3 plus 1 plus 5 plus 3 plus 1 plus 3 is 16. So that's a 9 degrees of freedom. That doesn't do anything for me. Is there any other restriction that just to be sure, I'm going to redo. It's 10 plus 18 plus 11 plus 12 plus 7 is 70 minus 45 is 25. And forgive the background noises right now. Animals are going crazy. So it's 25, and then we can be 3 plus 1. Let me move this again. Okay, 3 plus 1 plus, and then this would be 8 in this box minimum. Oop, plus 1 plus 8 plus another 1 plus 3. So that's 16, yeah. So there must be more to this. So 9 degrees of freedom means that any of these can be increased, but only one of them can be increased. Is there another pattern? I mean, I could take them together. The problem with taking them together is that there's this repeated center. I did notice this 8 here. I mean, we might as well remove those 8s, but it doesn't affect this sum at all. Okay, well, let's experiment with them together and see what we can figure out. So this 18 cage got repeated. So I think we should bring up our calculator again and just add up all of these cages. I'm really not going to be able to put this anywhere useful. Okay, so I'll just move it around. 5 plus, I'm doing the top left diagonal first, plus 7 plus 10 plus 18. I have to remember not to repeat the 18. Plus 11 plus 12 plus 7 was our 70. And then we can add 14 plus 18 plus 19 plus 22 plus 20. So we have 163 total. I suppose another thing to notice, well, I see it, is there's only one cell in this whole box that's not in a cage, but we can't really do any tricks right now to figure out what that would be, as far as I can tell, because we have too much poking out. So anyway, 163. So these diagonals each add to 45, but if the center were 1, then that 1 would get double counted. And so then they would actually together add to 44. Sorry, 89 is what I meant to say. One diagonal would not count the 1, so it would be 44 plus 45, so that's 89. Or it could be a 9, in which case the 9 gets double counted, and so we end up counting to 81. So we're anywhere between 81 and 89. And we also know what the individual boxes add to. There's definitely something going on with that. Sorry, I keep pulling this off screen, so we maybe looking at the Sudoku is better. So 163. And so if we were to subtract 89 from that, that's 74. So we're anywhere from 66 to 74 where we don't have these diagonals. So these cells that I'm about to highlight, like them blue, these add to anywhere between 66 and 74. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, wait. Don't want to include that one. 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 cells that add to anywhere between 66 and 74. It's an average of 4.4. That's not a great average to have. And that's probably because these have to be mostly high and these have to be mostly low. I say mostly because this one has 9 degrees of freedom and this one has 3 degrees of freedom. So, darn, I was really hoping I'd be able to figure out this break-in faster, but no luck there. Just thinking about what this means. Do I take them separate? I feel like taking them separate was a bit more fruitful, but does it have to do with this extra cell when looking at this diagonal? I don't see how that... Okay, well, maybe I should do a little bit of regular killer and see if anything pops out here. So let's remove these highlights. That's weird. Let's remove the highlights. Okay. So I feel like a lot of these along this diagonal are pretty restricted now. So for example, this also has to be 5 through 9. So we can add to 14. So whichever one we have here is going to be the 14 minus that. So 5 through 9 is 5 through 9 here, because 9 plus 5 is 14. This 19 cage at minimum adds to 11. And so at maximum, this can be 8. Oh, no, wait. At minimum, this... How am I thinking about that? At maximum, we add to 18, where we'd have a 1. And at minimum, we have 11, where we go to 8. So this can actually just can't be 9, which is... I don't even know if that's worth marking. Because we could be like 5, 6, 8. All right, let's move on. How about this 22? So at minimum, we're 11. There's no way we can be 11. In fact, this can't be 5 at all, right? Can it? Well, what can we do? 5, 9, 14. Yeah, we can. That would make this an 8. At maximum, we're 18. So at minimum, oh, sorry, at maximum, we're 17, 9 and 8. Right, we can't be, sorry, I'm going back to here, because we can't be 9 and 9 for 18. We'd have to be 9 and 8 for 17, so this can't be a 1. I don't know if that does anything, but I figured I'd do that while I remember. So 9 and 8, and that's because digits can't repeat in a cage. 17, you have to add 5, so this is at minimum 5. We have 2 5 through 9s on this. I just don't see what 20 would do here. If this were a 5, these would add to 15, which would be, what, 9 and 6 or 8 and 7? We can go all the way up to 9, making 11, and there's a lot of ways to make 11. But I guess that means we can't have a 1? Do we need to ask the question, where does 1 go on this diagonal? Because... So, just to show, if this were a 1, there's no way to add to 20, because these two would have to add to 19. And in fact, does that mean it can't be a 2 either? 2 would have to add to 18, and we can't repeat. So we can't be a 1 or a 2. So these are 3 through 9. On the 18, we could be a 1, because we could be 1, 9, 8. So these could be 1. On this 18, same deal. $14 can't have the 7s because they'd repeat. All right, let's look at some of these other. This has to be 1, 2, 4. I know that at least. This 5 is 1, 4, or 2, 3. Seven is 1, 6, 2, 5, or 3, 4. I feel like adding was more fruitful than this, but to make 10, There's a lot, I think there's a lot of ways to make 10 and 3. But what's our maximum? Our maximum is 7, so we can't exceed 7. Because we could do 7, 1, 2 to make 10. To make 11, we could do 8, 1, 2, but only here. Okay, so where does 8 go on this diagonal? Obviously can't go here because of the 8, given 8. Can't go here because of that given 8. Can't, yeah. That means our center is 8. That'll help. Okay. That's very helpful. So for the rest of this box and the both diagonals, we can remove any 8s. And that changes our, does that change anything? No, because we were deciding 9/8 on this diagonal. This can be 9/7 now, so that actually changes that removes a degree of freedom. Because we can't have, if you remember these blue cells, they had to add to, I want to say 66. But the way we did that is having a 9/8 here. And now there can't be 9/8. 9/7 is the max. So I can remove the lowest degree of freedom from all of these, and that might change our equation a bit. This can't be 5, so this can't be 9. Okay, so do I do these again? We said we couldn't have a 1 or a 2 in the 20. I don't think that it was affected by the fact that this was minimum 5. Which one was affected? How did I get 5, 6 here? Oh, I guess an 8 was removed from here as well, which would remove the 6. Six, 7, 9. So if these wanted to add to 12, so we can't have a 1 in here anymore, I think. Yeah, so how would we put a 1 here? So if this were 1, these two would have to add to 17. The only way to make 17 is 9 and 8. Well, this can't be 8 because of this 8, and this can't be 8 because of this 8. So actually, 1 can no longer go here. 1 can't go here, or here, or here, because there's an 8 there now, and 1 can't go here. So we can actually place the 1 here on this diagonal. Removes a 1 from the rest of the box. This was the kind of odd man out. So we have a lot more information about the full sum. I'm going to see if I can glean anything else first. Because the more info I have, the more likely I'll actually benefit from doing that sum. So there's an 8 up here because of these two 8s, and this can't be 8. Right, because we can't put an 8 in a 10 that has 3. It's an 8 here somewhere. I'm just really quickly looking to see if there's any triples, quadruples, doubles. Like these marry up pretty well. Oh wait, we should be able to get this now. We have the 8 and the 1. Does that force a 9 in here? Yeah, so that's a 9. That's quite limited now. So if this were a 6, these have to add to 13. Well, we can't make 13 with a 2, that's for sure. Can't make 13 with a 3. So we're either 4, 9, 5, 8, or 6, 7. So we can't be a 7 either. I think there's too many possibilities here, but yeah, because these could add to 9 even. But they can't use 1, 8, so they would be, if it were 9, it would be 2, 7. The only thing I haven't done is fill these. So if we're a 6, we need to add to 12. So we can be 3, 9. We can be 4, 8, 5, 7. If we're a 7, we need to add to 11. So we could be 2, 9, 3, 8, 4, 7, or 5, 6. I mean, really, we've already filled everything except 1. And we can't be 8, so that's unhelpful. Then again, they're the only ones that can be 2 on this diagonal. So the 2 is somewhere here. Oh, so they have to have a 2 in them? So that means the other 2 have to add to 16. So this can't be 6. And the other one's going to be 7, 9. Maybe I should have looked at that earlier. So this is 2, 7, 9. Wait, adding to 16. Is there another way? 8. 8 and 8 is 16, but that, yeah, there's only one way to make 16, 7, 9. So 2, 7, 9 in here forces this to be 8. That places this, oops, the 6. Remove 6 from the rest of the diagonal. Okay, let's do a little thought experiment here. If this were 7, that puts 2, 9 on the diagonal, which means we can't have a 2 or a 9 on the diagonal anymore. So for lack of a better way to do this, I'll fill that in. So that removes 9s from these. But also this 7 removes all of our degrees of freedom. So just to double check that, I have to use maximums on everything else. So 8 plus 7, I have to use 9, I have to use 7, I have to use 9, and then 9 and 8. And then I already have a 9. So that adds to 66, which is what it needed to add to. So this is 9, this is 7, this is 9. Oops, hitting the wrong buttons. Still hitting the wrong buttons. All right. So, and then that's an 8, 9 pair. But we've also, okay, I mean that, because this is the same cage, that forces the 8, 9 like this. So that fixes basically what the rest of these are. So to make 19 from here, we have 16, we need a 3. Is there a reason I didn't put 3 as a possibility here? Could have just been a mistake. I'm not seeing why I didn't put 3 on the 19. So that can be 3. 17, we need a 5. Oops, a 5. And then these need to add to 11 without a 5. So 4, 7 is the only option there. That seems to work, unfortunately. So I'm going to, whoops, too much. Okay, I'm going to add a 3 here. So what else? I'm just trying to restrict any of these to not be their lower value. So for example, can this one be 7? It seems less likely that this could be 7. So we'd have to put the maximums everywhere else. Oh yeah, we can't repeat the 7. So this isn't a 7. So can this be a 7? This would be, I believe, 9, 8, like this. This would be 7, 9, 7. Removes 9 from the diagonal. Wait, why did I put a 7 there? 9 removes a 7. Ugh. 9 removes a 9. That removes 7 from the diagonal. So 22 minus 7 is 15. These have to add to 15. That isn't possible. Let's double check this sum here. So 8 plus 9 plus 7 plus 9 plus 7 plus 9 plus 9 plus 8 is 66. And we need 15. So this obviously can't be 5 if we need 15. So this would have to be 9. Which is obviously leaves 6, right? So, but if we put a 6 here, there's no way this adds up correctly. So I think I just proved that can't be a 7. So this is a 9. Yeah, because it can't be 8. So that's a 9. That removes 9 from these. What else does that do? So how do I actually make 22? The 9 here. Can I do it with the 5? So 14, yeah, I could be 9 plus 5 is 8, or I could be 9 plus, or 16, sorry, not 9 plus 5. 9, 5, 8 is what I mean, because that's 14 plus 8 is 22. Or I could be 9 plus 7, which is 16 plus 6. So this can't be 7 anymore. So 9 up here somewhere. Well, can this be 6? We said 6 places the 7 here. That does force a 9 here, which we need. It forces this to be 9, 7, and 9. Yeah, now we can't hit 20. There's no way. I mean, even if these were both 5, we'd only be 19. So this has to be 8, which puts a 5 here. We're doing it. We're doing the thing. All right. That can't be 5 anymore. Does that affect this sum? Can this be 6? Yeah, this can be 6, 4, 9. Or 7, 3, 8. Or sorry, yeah, 7. 6, 4, 9. Can it be 7, 4? 7, 4, 8. Or 7, 3, 9. Can't be 6, 3 anymore. We still haven't found our 2 degrees of freedom yet. Should we look at this 20? Can we be 3 still? So if this is 3, we need 17. There's no way that's going to happen. So these can't be 3 anymore. Well, these can't be 3, so this is the only 3 on the diagonal. Removes 3 from these cells. Can they be 4? So we'd have to, if this were 4, we'd have to add to 16. That would be 9, 7. Can we be 6? We have to add to 14 using these 2. There's no way we can add to 14 using these 2. There's just no combination for it. 13's our maximum. Or sorry, we'd be 13 with 9, 4. 9, 7 is 16, and 7, 4 is way too low. 11. So this can't be 6. So we're 4, 7, 9. And the 4 has to be on this diagonal. Well, I'm glad I figured out this could be 3, because it turns out it had to be 3. And just to make sure, yeah, 4, 7, 9. 4, 7, 9 doesn't add to 20. Yeah, it does. What am I thinking? 7 plus 4 is 11, plus 9 is 20. Okay. Now you guys are realizing why I pull out calculators. All right, so wow, I have a lot, but it doesn't feel like it's quite cracking yet. Okay, so this 5C's up here. These can't be 5. Oh, I don't know how the, oh yeah, so this is 10 and 3. I have to remember that. I was going to say there can't be a 5 in the 10, but it's 10 and 3. This can't be 3. These can all just be, it's what, 2, 4, 5, 6, 7. Yeah, these are literally anything that the box can be. We have nothing on the other diagonal yet, other than the center. We got 2, 7, 9, we got 4, 7, 9. So I guess the question to ask is, can this be 7? Seems to be working so far. That puts a 4, 9 pair here. So these can't be 9, which puts a 9 here, which is what we want. And then we'd have to be 9, 7, which does not add to 19. Yes, it does. I'm going crazy, guys. I'm absolutely actually going crazy from too much adding. Exactly, that's 19, so that works. So, well, with the 3 here, yeah. So we're 7, 3, 9. Yeah, that's the only option, isn't it? If this were 8, what would I'd have to have another 8. That doesn't make sense. All right, yeah, we're 7, 3, 9. So one of these is 7, one of these is 9. So this is like a 7, 9 pair, and they both see that, so that can't be 7. And just in case you forgot, the reason I'm saying it's a 7, 9 pair is because this has to add to 66 exactly. And the only way for that to happen is if this is 7 and this is 9. We can double check that because my memory is not so great. But 7 plus 8 plus 9 plus 9 plus 7 plus 9 plus 9 plus 8 is 66. So that was assuming that's a 7 and that's a 9, but it's obviously interchangeable. So we got our 7s in this box. This is 2, 4, 5, 6 as well. Is there any reason to think one or the other of these is 7 or 9? I don't think at the moment. Yeah, so a 9 here removes the 7 from these two, placing a 7. A 9 here removes the 9 from these, removing the 7 from here, placing. So, yeah. So removing a 7 from here removes the 5. This can't be 5. Is there anything else like that? I honestly can't tell if I've actually got the correct break-in or if I'm just chiseling it instead. Well, this can't be 9 anymore. So 9's up here. Oh, if I could... This 8 sees here, so we can actually place this 8. Is it just Sudoku that I'm missing? We have a lot of 9s. We don't have a lot of repeat digits, though, because they're all on the diagonals. But 8s. 8 here. Okay, 8. can't be... So I think 8's here or here, which isn't super helpful, but it's something. Oh, okay. This 8's up here. So we have this 8 and this 8. Are we going to finish the 8's? Yeah. 8's here. Here. I think that's all the 8's. Yep. 8's are done. Sweet. Don't have to worry about 8's anymore. In that diagonal. Where does 9 go on the diagonal? Just here? Yeah, now it's just here. So we have this 9. That places a 3. Oh, so that just gives us this. This can't be 5 anymore, because this can't be 2, and this adds to 7. This can't be 2 because we removed it from here. And that's important because where does 5 go on this diagonal? It's locked into this box now, here or here. So these two aren't 5. Not sure if that does much, but it's info. Boy, this puzzle's not giving itself up. What a long solve. This can't be 3. So that can't be 2. What am I... How do I have a 6 in here? How do I have a 5 and a 6? This is a... Okay, sorry. It's true this can't be 3, but I was interpreting this 5 as the cage total. It's not. That 11 is the cage total. Very confused for a second. Yeah, so this could be 6, 4, 1, for example, to add to 11. Two, 5, 4 works. 4, these would have to add to 7. 5, 2 works. Or 6, 1. And then 6, we'd add to 5. So we'd be 4, 1. This way. Is it interesting enough to record that down? Did we eliminate anything? Okay, so I'm going to use these as proxy for these two to record down the possibilities. So this one's a 2. These have to add to 9, so that could be 5, 4. We can't use the 2 because we don't have a 7. We don't have a 5. We don't have a 3, so it would have to be 5, 4. So if this were 2, that's 5, 4. If this were 4, then we have to add to 7. So we don't have 2, 5. We don't have 4, 3. We do have 5, 2. And we do have 6, 1. Just disappointing, but... And then if we were 6, we need to add to 5. So we'd use 4, 1. So that means this can't be a 2. It's a lot of work to remove 1, 2, but... Let's see. Are there any other cages to work on like that? Like maybe the 10 cage? Okay, so I'm going to use these two to proxy these two. Actually, I'll just I'll fill this one. So a one here. These two have to add to 9. So how can we do that? We can't do 1, 8. We can do 3, 6. We can do 4, 5. We can't do the 6, but we can do 7, 2. Okay, if this is a 2, we need to add to 8. So we can't use the 1. We can do 3, 5. Well, we already know 3, 4, and 7 are possible, but can we do the 7 or the 6 with the 2? What do we have to add to? 8? Yeah, we can do 6, 2. If we're 4, we need to add to 6. That gives us the 1, 5. But the 4 still can't be used. With the 6, we have to add to 4, so with the 4 definitely can't be used. We'd actually have to be 1, 3, which isn't possible. So this can't be 4. Sorry, not 4, 6. 6, these have to add to 4. There's no way to add these to 4. So this isn't 6, and then this 4 can't be used. I guess another way to put that is these two would have to add to 6 using the 1 or the 2. So we would need a... Wait, 2 and 4 works. Oh, no, we can't use the 4 either, right? So we need to add to 6 without using a... Is that ever actually possible to have a 4 in a 10 cage then? Well, yeah, 4, 1, 5 would work. But we just don't have that. All right. So this isn't 4. Does that mean anything for... Not a lot. So this 5 is fine, 7's fine, 10's fine, 18's done, 11 we just did, 7 has 1 combo. That's all we're going to get out of that. And it was a whole lot of nothing, if you ask me. This can't be 3. 3, I said. What can these be? 1, 2, 3, 4, 5. It's not a 1. I can't help but feel like I'm just missing something really important about this diagonal with the greens and the blues or something along those lines, but I'm just going to do the addition one more time. I'm going to do the... I mean, we have the 3 placed now, so maybe that did something. I'm not too hopeful about it, but let's find out. So these cages, let's just add them again. 5 plus 7 plus 10 plus 18 plus 11 plus 12 plus 7 minus 45. The blues add to 25. That's what we had before. So we already have 9 and 1, and then another 3. So the rest have to add to 12. So what's our minimum? Our minimum is here is 1, 2, like that. So 3 plus 1 plus, this can be a 2. If this were a 2, this could be a 6, making 8. No, we couldn't be a 6. So we'd be a 5. 7. Wait. Yeah, and then would be a 4. So if this were a 2, we could put a 4 here. So that's the minimum, is if there's the 2, 4 there. And then this can be a 1. I typed 24. But it was 3 plus 1 plus 2 plus 4 plus 1. That's 11. So if this wasn't 2, 4, what other option do we even have? 6, 6, 1? Adds to 7. That's more than 6. And then 6, 1 would go with a 4 here. So I think it can just barely be 6, 1 if we're all minimums. So 3, 4, 5 leaves us with 7 more. Yeah, so this could be 6, 1 still. But certainly this couldn't be 4. Yeah, we have 1 degree of freedom now. Okay, so with 1 degree of freedom, this can't be 3, 4. So we now have a... Do that again. This can't be 3, 4. So this has to be 3, 4. This can't be 4, 5, or 6. And this couldn't be a 3. No, this could this be 1, 3? Could this add to 4 instead of 3? Yes, it could. Okay, so with 1, 3 here, to add to 7, we're 6 or 4. This can't be 4 anymore. So we need to add to 9 or 8. So to add to 9, we can't use a 1. Can we use a 3? Yes, 3, 6. 4, 5. Can't use a 6. Sorry, I should keep track of that over here. So if we're a 1, we can be 3, 6, 4, 5. We can't be 6, 3. We can be 7, 2. If we're a 2, then we need to add to 8. So we still can't be a 1. So that removes the 1 from here. 3, 4, 7. Can we be a 6 to add to 8? Yeah, 6, 2 would add to 8. So, okay, so that eliminated 1 from here. And that actually means 1's down here. It's the only place on the diagonal for it. So this is not a 1. It's progress. These we said could be either 6, 1 or a 2, 4 pair. So this can't be a 4. Wait, removing the 1 from here removes our degree of freedom. So just because I'm paranoid, I don't want to make a mistake. This now is minimum 2. This is minimum 6. This is minimum 1. And then this would be 1, 2 at minimum. And that adds to 12. Plus 3, that's 15, plus 10 is 20. Yeah, 25. So we're now minimums. So 2, making a 1, 4 pair here. This can't be 1, 6 anymore. So this adds to 6. Just to double check, if this were 1, could we add to 3, right? So that would require us to have 8 here. We can't put an 8 here. 1 plus 4 is 5. We can put a 6 here with that. So 1, 4 was actually smaller. Does that mess up my calculation? I'm paranoid. I'm gonna have to do that again. So the question is, can this be a 4? So let's do our 1, 2 for 3 plus 4 plus 5 for these, and then put a 1 down there. That adds to 13. That's still too much. Sorry, you couldn't see that, but that adds to 13. So this still can't be 4. Yeah, so that still forces the 1 out of here. This can't be 4 for sure, so that places the 2. 1, 4 pair removes the 4 from here. The 1 from here. That forces this to be 6. So that's 6, 1. This is 5. So with 5 here, these have to add to 6. Okay, so this is all working out. This is a 2, 4 pair. They can't be 2 2s or 2 4s. And they see here, so this isn't 2 or 4. What did I type? All right, that's 1 or 3. This has to be a 2, so that's 2, 3. This is a 2, 4, 2, 6, 6 there. I'll get to this 10, so this has to add 8, so it has to be 7, 1. So let's just add this to make sure that all works. Well, actually we can just check the cages. So that adds to 5, that adds to 7, that adds to 10, this adds to 18, this does add to 11, 12, and then that adds to 7. Okay, I think at this point it's just Sudoku then. So let's do it, I guess. 6 here. I placed so many things, I don't think I cleaned it all up. I'm gonna get rid of this highlighting. Okay, so one goes here, 3, 4, 1, 5, 6, 7 is left for this box. These can't be 1, 7, 6, 5 here. Okay, this can't be 6 or 1, so that's a 2, 3. This can't be 1. Oh, we already have 1 in the box. So that's 2, 3, 6. This, oh, these can't be 2, so 3, 6, 2. All right, here we go. This can't be 5. No, but this is 4, 1. So this is 4, 5. This is a 3. Two, 4, 5, 7. This is not a 5 or a 2. This isn't 2 or 7. This is a 4 or 5. But it's not a 4, so that's 5, 4, 7, 4, 7, 2, 5, 3. This isn't 1 or 5 anymore, so that's a 3, 4, 5. This is a 6, 5, 6, 7. That's a 2. This is a 1, 4, 1. All right, I'm pretty sure we're done now. Left for this column is 3 or 9, it looks like. So that's 3, oops, not 9. 3 or, well, it's not a 7. So 7 goes here. And 5? 3 or 5. So this is 3, 5, 4, looks like. 1 and 2. Wow, okay. Well, Joseph, you said that it was a break-in and then got easy, but for me, it was just tough the whole time. So I'm not sure if I missed the break-in and just sort of chiseled at the cages until I found some roundabout way to do it. Please let me know if there was like a cleaner way, or maybe you just kind of expected me to have seen those things faster. But either way, I mean, what a puzzle. Okay. I liked the idea of the staircases and it definitely was clear what the intent was. I just failed at piecing that together quickly. So thank you for the puzzle suggestion, Joseph, and I hope you guys enjoyed watching my solve. It was quite a long one, so I'm glad you stuck through it. And I'll put, again, like usual, put boxes on the screen for other videos that I recommend you watch. And other than that, until next time, thanks for watching.